Namaskar students, today we shall see a couple of more problems of the chapter indices. So let us start today's video. This is our first problem of today's video. It is telling that you have to prove that x plus y into x square plus y square into x to the power 4 plus y to the power 4 into this will go on till x to the power 2 to the power n minus 1 plus y to the power 2 to the power n minus 1 equal to x to the power 2 to the power n minus y to the power 2 to the power n divided by x minus y. So you have to prove this left hand side, whatever it is given, is equal to this expression. See how we can prove this. So LHS equal to, now just look at one thing. In the right hand side, you have x minus y in the denominator part. So if you have to bring x minus y in the denominator part, because in the left hand side there is no denominator part. Actually in the denominator part you have only 1. So if you have to bring the denominator as x minus y over here, like you have to bring the denominator x minus y. So you have to multiply x minus y in the numerator also for adjustment. So let us multiply numerator and denominator with x minus y in the LHS. So you have x minus y into x plus y into x square plus y square into x to the power 4 plus y to the power 4 till x to the power 2 to the power n minus 1 plus y to the power 2 to the power n minus 1. Which is equal to, now see, the first two expressions x minus y into x plus y. We all know what is the formula for that, x minus y into x plus y. That is, so if you combine these two, you get x square minus y square, because we know the formula of x square minus y square means x minus y into x plus y. So this two combines into x square minus y square into, now whatever is left, x square plus y square into x to the power 4 plus y to the power 4 till x to the power 2 to the power n minus 1 plus y to the power 2 to the power n minus 1 divided by x minus y, which is again equal to, now see, now what happens, next two terms what you have, x square minus y square into x square plus y square. So see, you have a minus b into a plus b type of expression over here. So a minus b into a plus b, what you have, a square minus b square. So a minus b into a plus b, you have a square minus b square. If this is a and this is b, you have to write over here, combine these two, a minus b into a plus b means a square minus b square. So x square minus y square into x square plus y square means x square whole square minus y square whole square. Now x square whole square minus y square whole square means, according to the law of indices, what happens, you multiply these two. So you have x square whole square means x to the power 2 into 2, that is x to the power 4. So simply I can write over here x to the power 4 minus, you have y to the power 4 into x to the power 4 plus y to the power 4 and so on, x to the power 2 to the power n minus 1 plus y to the power 2 to the power n minus 1 divided by x minus y, which is again equal to, see again same repetition happens. X to the power 4 minus y to the power 4 into x to the power 4 plus y to the power 4. So again a square minus b square formula. So if you combine these two, a minus b into a plus b, you have x to the power 4 whole square minus y to the power 4 whole square. It goes till x to the power 2 to the power n minus 1 plus y to the power 2 to the power n minus 1 divided by x minus y. Now look at the interesting part over here. This is x to the power 4 whole square means x to the power 4 into 2. So 4 into 2 is x to the power 8. So you have x to the power 8 over here minus y to the power 8 over here. Next term after this, what you have, see x to the power 4 plus y to the power 4. The next term after this was x to the power 8 plus y to the power 8. So after this term over here, what I have given dot dot means there are some terms over there. So that term is x to the power 8 plus y to the power 8. So again same process, if you combine these two, it will become x to the power 16 minus y to the power 16 and so on. So ultimately if you follow this process, what is happening? See, one after the other terms are getting absorbed. You had x plus y over here, after that it got absorbed into x square minus y square. Again this got absorbed into x to the power 4 minus y to the power 4. So the terms are reducing now. Ultimately a time will come after a finite number of steps, you will reach over here and you will have to write the term before this one. You will have x to the power 2 to the power n minus 1 minus y to the power 2 to the power n minus 1, because that is what it is happening. See, each and every time when we are going from this step to this step, this step to this step, what is happening? The term what you have x square minus plus y square, before that term you are getting a conjugate of that. Means conjugate means if you have x square plus y square, you are getting before this term x square minus y square. See, x square minus y square. Again you are having x to the power 4 plus y to the power 4. In the next step before this term, you are getting x to the power 4 minus y to the power 4. And the same process will continue. Ultimately a time will come in this term, the last term, it will remain with another term before it with a negative sign in between. Means the last term what you will have, that is equal to, after a finite number of steps, dot dot, after a finite number of steps, you will have x to the power 2 to the power n minus 1 minus y to the power 2 to the power n minus 1 into x to the power 2 to the power n minus 1 plus x to the power, sorry, y to the power 2 to the power n minus 1 divided by x minus y, whatever you have over x minus y. Now see this again, a minus b into a plus b type of thing. So you have to write this equal to x to the power 2 to the power n minus 1 whole square minus y to the power 2 to the power n minus 1 whole square divided by x minus y. Now whole square means what? X power something whole to the power again something, according to the law of indices what you can tell. So the power will get multiplied. So what will remain? It will be like this, x to the power 2 to the power n minus 1, it will get multiplied, multiplied means into 2. Similarly over here you will have same thing, it will get multiplied, so into 2. Now see, 2 to the power something into 2 to the power 1. So according to the law of indices, what happens? If the base are same, then the power gets added up. If it is multiplication, if it is division, power gets subtracted with each other. But over here it is multiplication, 2 to the power n minus 1 into 2 to the power 1. It is actually 2 to the power 1 over here. So if the power gets added up, what will happen? So it will be 2 to the power n minus 1 plus 1. Same thing over here, 2 to the power n minus 1 plus 1. So minus 1 plus 1 will get cancelled out. If minus 1 plus 1 gets cancelled out, what remains? X to the power 2 to the power n minus y to the power 2 to the power n divided by x minus y. This is nothing but the RHS. This is the process in which you have to solve this problem. This is the next problem. It tells that if m equal to a to the power x, n equal to a to the power y, and a square equal to m to the power y into n to the power x whole to the power z, then you have to show that x into y into z equal to 1. Now this is one part of the problem. At the last it is written under the brackets, under what conditions? There is a question mark over here. Under what conditions? Means this you have to prove x into y into z equal to 1, but under what conditions? So there are two parts. First we'll prove x into y into z equal to 1. Then we'll come on to what are the conditions under which this proof will hold true. See, it is given that m equal to a to the power x and n equal to a to the power y and a square equal to m to the power y into n to the power x whole to the power z. So let us start with this. It is given that m to the power y into n to the power x whole to the power z equal to a square, or m means a to the power x. So in place of m you can write a to the power x in place of m, a to the power x. Now m to the power y means a to the power x whole to the power y into n means a to the power y. So in place of n you can write a to the power y. Now n power you have x, so a to the power y whole to the power x. Total power you have z equal to a square. Or now according to the law of indices, these powers will get multiplied. So you will have a to the power xy into a to the power yx means xy only whole to the power z equal to a square. Or now see, the bases are equal. If the bases are equal, then the power gets added up. So you have a to the power xy plus xy whole to the power z equal to a square. Or now a to the power xy plus xy means a to the power 2xy whole to the power z equal to a square. Or now again same thing, the power will get multiplied. So you will have in the next line a to the power 2 xyz equal to a square. Let us write this one over here. This implies a to the power 2 xyz equal to a square. Now in both sides the bases are equal. If the bases are equal, then you can write this one as implies that the powers will be equal. If the bases are equal, then the powers will be equal. So you can write 2xyz equal to 2, or now 2 gets cancelled out, you get xyz equal to 1. You arrive at the point what you had to show. You had to show that xyz equal to 1. We arrived at that point, xyz equal to 1. Now come to the next part. In the next part, you have to show under what conditions. Means you have arrived at this part xyz equal to 1, but under what conditions? See over here, we overlooked something. What is that? I said if the bases are equal, then you can equate the powers. But what about the value of A? If the value of A is 0, then you cannot arrive at this line after this. Because see, if A is 0, what happens? 0, suppose 0 to the power 4, you can write as 0 to the power 4 means what? 0. That is equal to 0 to the power 2. That is also 0. So you can write 0 to the power 4 equal to 0 to the power 2. But after this line, can you equate that, okay, the bases are equal, so you can write 4 equal to 2? This is wrong. So this equation after this means that if the bases are equal, then you can equate the powers. This arrives at this condition that A cannot be equal to 0. A cannot be equal to 0. If A becomes equal to 0, then you cannot write this line after this. So this is the first condition, A cannot be equal to 0. Now see what happens if A becomes equal to 1. Suppose A is not 0, A can be 1. If A is 1, a similar type of problem will happen. See, 1 to the power, suppose A is 1. Suppose 1 to the power 4. 1 to the power 4 means 1 only. You can write that equal to 1 to the power 2 also. That is 1 only. So 1 equal to 1, 1 to the power 4 equal to 1 to the power 2. But arriving at this conclusion, you cannot tell, okay, the bases are equal, so in the next line I will write 4 equal to 2. No, that is not. So if A becomes equal to 1, same problem will happen. So A cannot be equal to 1. Similarly, A cannot be equal to minus 1 also. If A becomes equal to minus 1, same type of problem will happen. Okay. So these are the three conditions that A cannot be equal to 0, A cannot be equal to plus 1, A cannot be equal to minus 1. Apart from these three real numbers, A can be any real number. It does not matter. Accepting these three real numbers, A can be any real number, you will arrive at this conclusion xyz equal to 1. So for the last part, these are the three conditions that A should possess. So my dear friends, if you have understood the problems discussed today, do like my video, share this video with your friends, subscribe to my channel, and don't forget to follow my page. Till then, goodbye.